Hi everybody, these are our how-to directions on our moon finder, and hopefully if you've made the following moon finder in class with your moon wheel on it and your horizon line here. If you missed class, you should have hopefully gone to my website and built this, and if you haven't, go to my how to build it and do so before you finish watching this movie. At any rate, this wheel has a lot of stuff on it, and so I wanted to simplify it just for the purpose of directions, and I'm going to start just by one that's got no moons on it and just has the sun, and relate it to what we already know from shadow plots. Now I made this be the horizon, and just so it's easy to ask questions, I made it happen on the equinox where we had a sun up at exactly 6 a.m., sundown at exactly 6 p.m. The moon and the sun really work in this pattern all year long. The times just aren't quite as exact, and I did this to make it easy to ask questions. But what do we know? We know on the first day of spring or fall, the sun rises directly east, comes up through the day, it's in the southeast in the early morning, reaches its local noon or highest point during the day. At this point, it'd be 12 p.m. Starts to come down and get lower in the sky, and then finally sets in the sky. Well, the other thing we know is that the moon follows the sun's ecliptic. Not exactly, because it's not precisely on the orbital plane, but it's very, very close. So now I'm going to do a very simple one, one with just one moon on it. And the reason we did this instead of this is because we'd have had to make 8 of these with 8 different moons, and we can get all of them on one, even though we know the moon is only in one of these positions at any time given, at any given time of the month. So let's look at this same thing. If now I put this at our sun-up position, if it was a third quarter moon, which is what this is, it would be way high in the sky. It would be at its local noon in the morning. And as the sun came up, the moon would appear to move across the sky as well. Really, it's the earth turning underneath them. We know that. But by 9 a.m. in the morning, the moon's going to shift it into the southwest sky. By the time we hit local noon, the moon is going to be setting, and for the rest of the day, we're not going to see it, because it's now dropped below the horizon. Conversely, if we switch to a first quarter moon position, notice at 6 a.m. in the morning, there's no moon in the sky at all. We'd get up and we wouldn't see any moon. If it was a little before 6 in the morning, it was pitch dark, you still couldn't see a moon, because it's not where we can see it at that point. If we go early morning, we still can't see a first quarter moon. If we go to local noon, we're probably still not going to see a first quarter moon, even though you can start to see it poke up over on this side, because it's right on the horizon. It isn't going to be till late in the day that that moon's going to come up enough for us to see it. And even if we go, now is at 6 p.m., if I move to 9 p.m., which is one more of these increments, it's going to be completely dark out, but I'm going to still be able to go out and see the moon. By midnight, though, that moon's going to be going down. Okay? So that's how this basically works, and it's a little easier if we only have to look at one moon at a time. We, again, didn't want to have to make a different wheel for every possible moon phase, so we just put them all on one wheel. And a good way to think of this wheel as well is go back to our golf balls and moon phase activity we did in class, where your head acted as the Earth. And if you think of it that way, that's the Earth right in the center of this wheel. Think about that. You face toward my light in class, and then you move the golf ball around your head, and you saw every one of these positions on, or every one of those moons, depending on the position you were at. So now, let's relate this to some things we did on our moon data. First of all, I'm going to move this to where it's really early in the morning, after 6 a.m. And early in the morning, if the moon is in a waning phase, I'm going to be able to see it. I could see it if it was a waning crescent, it would be in the southeast sky. If it was a third quarter, it'd be kind of south. Waning gibbous, it'd be kind of in the southwest sky. But I would be able to view all of those early in the morning, and that's why all of my waning moon observations occurred early in the morning. If it's a little before sunup, I can still see all those moons. Might even be able to see a little sliver of a full moon. Okay? Conversely, if it gets into the evening hours, Now all of a sudden, if it's a waning moon, I can't see that if it's in the evening because it's already gone down. If it's in a waxing phase, though, I can see it. And I'll not only see it in the early evening, I'll be able to see all of them for a while after the sun goes down as well. Okay, so we see waxing moons in the evening. We see waning moons in the morning. Notice all of the sun-moon angles here hold true about what the angle would be from you and the sun. Okay? So, let's try a couple of questions on here like you would see on the test. If I said, for instance, it was 3 p.m. and you saw a moon in the southeast sky, well, what moon is it? Well, first thing I have to remember is sun is my time minder. If the question poses it's 3 p.m., you got to move your sun to 3 p.m. And then all you got to do, if I said I saw a moon in the southwest sky, there is only one moon you're going to see in the southwest when the sun is in the southwest sky. There's only one moon you'll see in the southeast, and that's a first quarter moon. If it's not a first quarter moon, there's not going to be a moon in the southeast sky. Okay? Another one would be to say it's 6 a.m. in the morning and you see a moon directly south. What moon is it? Well, you got to move the sun, your timekeeper, to 6 a.m. And then if it said you saw a moon directly south, well, the only moon directly south is going to be a third quarter moon. If it's not in the third quarter phase, you aren't going to see a moon directly south. Okay? Now, the reverse way of asking that is to say you see a certain moon in a certain place. What time is it? Well, let's say I saw a waning crescent directly south. I put my waning crescent directly south. If the question is, well, what time is it? All I got to do is go to my sun and look at the time. It's 9 a.m. in the morning. Okay? Sometimes the times can get a little tricky. For instance, let's say I said you saw a waxing gibbous directly south. Well, there's our waxing gibbous. Let's put it directly south. Now, our problem with time on this is we can't see the sun anymore. So how in the world do we figure out what time it is? Well, look at each of these is 3 hours. If you pull this up, the sun has moved one increment from its 6 p.m. spot, which means it's 3 hours after this. So if I say you see a waxing gibbous directly south, well, it's 9 p.m. at night. Okay? So that's a quick run through on here. I have another movie that's got some more versions of this that you'd be welcome to watch. I've got PowerPoints, but you really want to make sure you're well versed on how to use this before you go into your test. So thanks for watching.